convergence depends on x. Let's consider a power series.
So maybe I've got a power series, the sum n goes from 0 to infinity of some coefficients a sub n times x to the nth power.
Now suppose that I know that that power series converges absolutely when x equals 3.
So yeah, I'm going to assume that it converges absolutely at x equals 3, and then I want to know, what about at other points? What about at, say, x equals 2? Does it converge there?
Well, then it must converge when x equals 2. Let's see why.
Well, since it converges absolutely at x equals 3, that just means that the sum n goes from 0 to infinity of the absolute value of a sub n times 3 to the n, right? This series converges.
We can compare this to the same series when x equals 2.
Well, what I mean to say is just that 0 is less than or equal to the absolute value of a sub n times 2 to the n, which is less than or equal to the absolute value of a sub n times 3 to the n. And since this series, the sum of a sub n times 3 to the n, converges, that means by the comparison test, this series, the sum n goes from 0 to infinity of a sub n times 2 to the n, this series converges, which is just to say that the original series, when x equals 2, well, in that case, this series converges absolutely.
And of course, there's nothing special about the number 2.
So if x is any value, so that the absolute value of x is less than or equal to 3, that just means that x is in the interval from -3 to 3. If x is any value in that interval, then 0 is less than or equal to the absolute value of a sub n times x to the n. Well, that's just because it's the absolute value of something. But then that is less than or equal to the absolute value of a sub n times 3 to the n. So again, by comparison, right, that means that this series, the sum n goes from 0 to infinity, I'll just write a sub n x to the n, converges absolutely, because the sum of the absolute values converges, because I'm comparing with this convergent series.
And this is the usual case. This is usually what happens. So talk about this though. Let me be a little bit more formal.
Let me give a name to this. Let's call C the collection of all real numbers so that this power series converges. Or in words, C is all the real numbers x so that this series converges. It's a collection of numbers.
The big deal here is that C is an interval.
Well, here's the theorem. This collection of values of x where the power series converges, it turns out that collection of points is an interval, by which I mean maybe it's this open interval, maybe it's a closed interval, or maybe it's something more complicated, like some half-open interval.
We'll see a proof of that soon.
And since it's an interval, this collection of points where the power series converges is called the interval of convergence.